Alright, let's finish out the notes from yesterday. So, we talked about part A of this question, right? How fast are you going 16 seconds later after you've passed the bus? So, to find v of 16, right, we're given acceleration and we are given an initial velocity. So, we want the velocity 16 seconds later. So, to find this is kind of like final position, right? Except we're finding final velocity. So final velocity equals initial velocity plus change in velocity. So this is my acceleration function. To get change in velocity, I want to integrate acceleration. So if I take that antiderivative, I would get 8t to the positive 1/2. Evaluating that from 0 to 16, we found in class that that was 32. So 66 plus 32 gets me that my final velocity at 16 seconds is 98 feet per second. Okay, then to find total distance, we know that total distance is the integral of the absolute value of velocity. Okay, well, we just found our velocity function, right? This was my velocity function. So this is what's going to go in here. So this is going to be the integral from 0 to 16 of the absolute value of 66 plus 8t to the 1/2 dt. Okay, and remember we said that we're assuming anytime that we have to take the absolute value, that's going to be a calculator question. So if we plug this into the calculator, it would go math 9 from 0 to 16. And then remember, the absolute value button is under math, and then write 1 abs right here. So 66 plus 8x to the 1/2 power dx, and we get 1,397.333. Now our units here our units here 7.333 would be just feet, right? If we're integrating velocity, the total distance is 1,397.333 feet. Now, average velocity, okay, this is like average value, right? We just found the total distance traveled over 16 seconds. So to find average velocity, we can just take this total distance divided by the time. So 1,397.333 divided by the change in time. Right? So change in position divided by change in time is going to get me average velocity. So that's going to be about 87.333. And my units here, if we're talking about velocity, would be feet per second. All right. So let's take a look at the next one. And I added a part C onto here just so we can talk about that initial idea. So here, if we are determining displacement of the particle, okay, remember displacement is just where we are relative to where we started. So given a velocity function, and if I want to determine displacement over the interval 1 to 7, I'm just going to find the integral from 1 to 7 of my velocity function. So of negative t squared plus 7 minus 10 dt. Remember, don't forget your dt. Oops. So this one wouldn't be too bad to do by hand. Oops, I forgot my... Wait a minute. This should say plus 7t. I apologize. Put a t in there. Negative t squared plus 7t minus 10. There we go. So this one wouldn't be too bad to do by hand. Okay, we could take the antiderivative, plug in 7, plug in 1, but let's do it on the calculator here. So we'll go math 9, the integral from 1 to 7 of negative x squared plus 7x minus 10 dx, and we get negative 6. So negative 6, my units would be feet. And remember, what this means is the particle is 6 feet to the left of where it started. All right? So total distance traveled then, right? Total distance is the integral of the absolute value of velocity. So absolute value of negative t squared plus 7t minus 10 dt. And again, we can use the calculator. So math 9, the integral from 1 to 7 of the absolute value of that same function. Negative x squared plus 7x minus 10 dx. And so our total distance traveled is 15 feet. And remember, we talked about before, the calculator sometimes gets a little bit of an error. Right? If we have 5 zeros after the decimal place, we can assume that this value is actually just 15. All right? So total distance traveled is 15 feet. Okay, now find the position of the particle at t equals 7. So what we are given is an initial position and a velocity function. So if I want the position at 7, that's my final position, we say final position is equal to initial position. So I'm at negative 3 at s of 0. So I'm going to say final position is initial position plus displacement. So here we want the integral from 0 to 7. Okay, so we do have to redo the integral, right? I did not find the displacement from 0 to 7 in part A. So negative t squared plus 7t minus 10 dt, and we can plug this into the calculator. So math 9, 0 to 7 of my function, negative x squared plus 7x minus 10 dx. Oops, what did I do? Oh, put a subtraction instead of a negative sign. There we go. So my displacement is negative 12.833. So this will become negative 3 minus 12.833. So we would get negative 15.833. All right. Let's actually skip this graph here. Let's go to the last problem here. Let's go to this graph. So on this one, we are given a velocity graph. Okay, AP test seems to love questions like this, where you are given a velocity graph. So, for what intervals of time is the particle moving to the right? Justify your answer. Well, the particle is moving to the right whenever velocity is positive. So, if I look at this graph, velocity is positive here, right? Velocity being positive, if I'm given the velocity graph, just means it's above the x-axis. So, say from 0 to 3 and 7 to 8. And we can just say that our reasoning is because v of t is positive on these intervals. Now, when is the particle slowing down? Okay, slowing down, remember, we said meant that velocity and acceleration have opposite signs. Or, in terms of a velocity graph, that means that we are getting closer and closer to the x-axis, or the t-axis. So that would be this piece right here and this piece right here. Right? So we would say from 2 to 3 and 6 to 7. Okay, and our reasoning could be because velocity and acceleration have opposite signs. Alright, so when is the particle stopped and changing directions? Okay, so the particle stops whenever velocity is equal to 0. Okay, well that occurs right here, and right here. However, it says when is it stopped and also changing directions. That would only occur at 3 and at 7. Okay, because remember, whenever velocity is positive, we're moving to the right. Whenever velocity is negative, we're moving to the left. So what happens right here, the particle is going to the right, slowing down, it stops at t equals 3, turns back around and starts going to the left. So we would say at t equals 3 and t equals 7, and our justification could be because velocity changes sign at these values. All right. Then part D, on what time intervals is the acceleration 0? Okay, well, acceleration is the derivative or the slope of velocity. So the slope of this function is equal to 0 here between 1 and 2, and here between 4 and 6. So we can say 1 to 2 and 4 to 6 because the slope of our velocity function is 0 on these intervals. All right, so that's it for the notes. I did want to mention something about the first homework question. Okay, so remember the homework then is 2, 4, 6, 8, and then 9 through 12 on that worksheet that I gave you yesterday. So I got a couple of questions on number 2 here. It says, given that the acceleration of the particle, a of t, is negative 4 feet per second squared. So that's my acceleration function, right? That's the whole function. And then v of 0 is 12 feet per second. So this is an initial value. Find the average velocity of the particle over the interval 0 to 8. Okay, this is kind of a trick question, right? So on this one, we want to find find the average velocity. Okay, well, average velocity, if I'm given acceleration, I just want to find the slope between my two. If we're given acceleration and I want to find average velocity, we don't want to find slope, we want to find the integral. So for part A, our setup, okay, finding average velocity for 0 to 8, I'm going to say I want the integral of acceleration from 0 to 8, and that function is just -4. So I would just have -4 dx. So this will get me the total change in velocity, but I want the average. So I'm going to multiply that by 1 over 8 minus 0. Okay, so this would be my setup for part A. Then B, find when the instantaneous velocity equals the average velocity. So we're going to get a value for this. Right? So I do want you to find that value on your own. So then part B, we want to find the instantaneous velocity. Okay, well, instantaneous velocity is the antiderivative of acceleration. Right? So if A of t equals -4, V of t will be that antiderivative. So that would be -4t plus c, right? But we're given this initial value, right? We're given this initial value. So I can say I know that V of 0 equals 12, but that would also be -4 times 0 plus c, which -4 times 0 is obviously 0. So what this means is that c equals 12. So what that means up here is that my velocity function is -4t plus 12. Okay, so hopefully we can find or finish out part B from there. All right, then part C, find when velocity is increasing. Okay, velocity is increasing whenever acceleration is positive. Right? Velocity is increasing whenever acceleration is positive. And then part D, find total distance traveled. Total distance is absolute value of, or the integral of the absolute value of velocity. Okay, so see if you can finish out this question with those hints. If you need help, please certainly ask me questions, send me questions. And again, try to finish up 2, 4, 6, 8, and 9 through 12.